our motto determine V naught with the help of Thevenin's theorem. So how can do it? First of all, if you consider 3 kilo ohm is the parallel to V naught, it means that is this 3 kilo ohm behave as a load resistance. So we have considered that is load resistance. After that, if this one is load resistance, so first of all this one is removed and this circuit converted corresponding to Thevenin's equivalent like this one. Okay, and after that connect RL and determine V naught. Okay, so first of all our motto determine RTH and VTH. How can determine VTH and RTH? VTH means V of OC, that is first this one remove and that is plus minus, this one is open circuit. Okay, now apply KVL in this loop, -6 here I plus I and plus 2I, this is equal to 0, so I is equal to 2 milliampere. After that apply KVL in this loop, minus to plus minus V of OC, minus to plus minus VA by 2 plus 2 into I. Okay, after that put this value V of OC is equal to VA by 2, VA means 2 volt, so okay, and this is 2 into 2, that is VA by 2, that is 1, so 1, okay, 2 by 2, that is minus 1, and 2 into 2, that is 4, 4 minus 1, that is 3 volt. So V of OC means VTH is 3 volt. Now next target is RTH. So how can determine RTH? First of all, we have focused on data circuit. I know that all independent source reduced to be 0. First of all independent, that is 6 volt is reduced, remove. So reduced to be 0 means its behave as a short circuit, that's why short circuit. After that, this one is a voltage dependent voltage source, clear? That's why this voltage is not removing. Okay, and corresponding to XY terminal, we have considered, if you consider 1 ampere current source or 1 volt voltage source, but we have considered, if you consider 1 ampere current source, then determine voltage across this current source. Okay, so what about V? V is equal to I into RTH, so RTH is basically V. If you determine V, means you can find out RTH. So how can determine RTH? Clear or not? Basically our motto determine V. If you determine V, then it is RTH. So how can do it? First of all, if you consider that is 0 volt, if you consider that is ductum node, clear? And this one is voltage V1. I know that V1 minus 0, okay, or you can say apply KVL in this loop, then got minus to plus minus V1 minus to plus VA, this is equal to 0, so V1 is equal to minus VA. Clear or not? If any doubt, then put right now here, apply KVL, minus to plus minus V1 and here minus VA, this is equal to 0. Clear? Then V1 is equal to minus VA. Now next target, apply KVL in this loop, minus to plus minus VA, minus to plus minus VA by 2, minus to plus minus VA is equal to 0. After solving, then we got V is equal to minus 3 VA by 2, and if VA is converted into V in the terms of V, so minus 2 by 3 V, and this VA value put here. Okay, this VA value put here, then we got 2 by 3 V. Okay, clear or not? So after that apply KCL at that node, 1 ampere, this is equal to I1 plus I2. I1 is written V1 minus 0 divided by 2 and I2 is V1 minus 0 divided by 1. Okay, after solving this we got 3 V1 by 2 and that is 3 by 2. V1 is, what about V1? V1 is 2 by 3 V, put this value and we got 1 this equal to V, it means V this equal to 1. V is nothing, that is RTH, so RTH is 1. Clear? 1 kilo ohm. After that, I know that what about VTH, that is 3 volt, and what about RTH, that is 1 kilo ohm. This will put here. And what about RL? RL is 3 kilo ohm. Okay. After that, apply voltage divider rule. If you apply voltage divider, V0 this is equal to VTH divided by RTH plus RL into RL. Okay. Put this value and we got 2.25 volt, that is 9 by 4. So we got final answer is 2.25 volt. Make it.